Welcome, everyone, to another episode of Force Tech Talk. Today, I have the privilege of stealing Ben away from all his engineering activities. And we're going to talk to you about what FFF means in relation to obsolete semiconductors. So, we'll go into what it means, why it's important, and it's something that we get asked frequently, kind of explaining a lot. And it is just a complicated term. Sometimes you just hear FFF and you think, what is that? So we've got some FAQs in. So I'm going to quiz Ben on all things FFF. So the first question that I have, what does form, fit, function mean in the context of obsolete semiconductors?
I mean, inherently, form, fit, function in that world means exacting replacement to the original component. That goes beyond just the electrical characteristics of the part. It's also obviously the physical dimensions of the part,
Mhm.
and also the original environmental qualification that the product would have gone through. Both in terms of sort of internal destructive testing that the product would have go through to sort of qualify the lot, and also the additional environmental testing, things like temperature cycle, centrifuge testing, um, burn-in testing, and yeah, sort of and on. Really,
Yeah.
it's just really ensuring that the customer is getting a direct replacement for the component that they were using in their legacy application.
Yeah, good nutshell. Yeah, I think most people they hear FFF and it is just an alien concept, and then as soon as we say it's form, fit, function, that gives a little bit more information of what it actually means. But if we broke it down by what each of those could be in terms of examples, so talking about form, you're talking about size, shape, talking about package, that kind of thing, pin out. Fit, like you said, we're talking about how it interfaces electrically, mechanically, a literal fit in someone's system, and then function, talking about the intended operation, that kind of thing. Okay, so the second question I have, why is form fit function important for legacy systems? And I'm going to talk about aerospace and defense because that is our primary industry that we serve.
Yeah, I mean, it's important because customers that we sell into will have spent millions and in some cases billions of dollars or pounds originally qualifying that system and ensuring that it's if it's a fighter jet, for example, and we're providing a component on either the heads up display or engine management system or anything along those lines. um, Anytime they make an internal replacement of a component, they have a whole suite of internal verification testing that it needs to complete to then be suitable, and the customer will define a sort of an aftermarket test in terms of replacing product on those boards. But the closer we can get to the original component, the less pain they have to go through. There is generally no world where if we're providing a manufactured replacement that isn't franchise traceable to the original. Effectively, if it's not the exact component they were using, franchise traceable to the original manufacturer, which is what you would attempt to do for a distribution chain initially, and then once you've realized, okay, well, there's no franchise goods there, then the next step would be, well, is there non-franchise goods, and can we accept non-franchise goods, and what kind of testing would we do to do that? And then sort of, after that point, then they're looking for, well, we can't get that either, so let's look
Mm.
for a solution. And that's where they're going to want the component to be as close to the original as possible.
Yeah, and I think working in a world with aerospace and defense, where if you have to redesign something, not only does that add a load of qualification, but the amount of money that that adds onto a project
Exactly. Yeah, the
is a
cost is.
killer sometimes, whether you're talking pounds, euros, dollars, whatever currency it is a huge, huge investment. So providing something that is form fit function without having to go to the extreme of a redesign, certainly I'm sure would make more commercial sense to some projects. And as we know, legacy systems, they have decades long of a lifespan, and components go obsolete before that. So this is an interesting one. Can a component with a different package still meet form fit function requirements?
Yeah, I mean, there's various things to consider there. Customers in our world routinely do things like replacing original hermetic ceramic components with plastic components. That's
Yeah.
not something that we would generally provide, but that is, a concession that a customer might take on an application. Perhaps the whole board could be conformally coated or be protected from moisture ingression in some other manner. But that's a situation where, yes, okay, well, the component would fit as a footprint onto their printed circuit board, but then the actual package is different. In our world, you know, having a non FFF package would mean that, yes, it fits on the board correctly,
Hmm.
but the overall component height might be, you know, fractionally higher. You could
Yeah.
be talking anywhere from, quarter of a millimeter up to a millimeter taller than the original component, or these are small engineering variances that, whilst the original component fits on the board perfectly, the customer then needs to evaluate and ensure, if it's a particularly tight fit or there's a component nearby, or that kind of thing. So, that's a situation where the original part is a drop-in replacement, but it's not dimensionally accurate
Yeah.
versus the original component. And that's something that we, when we're providing a replacement package or a package that we design and have manufactured. Um, it's something that we will communicate with our customers and give them a comparison document which shows the dimensional variances and things like that. And that obviously extends not just to a package; that extends to any kind of die variances. Perhaps the original die that the customer was using was a older die revision, and there's a later die revision
Yeah.
available, and ensuring that the actual characteristics of that product have not changed through the various die revisions. A lot of the time when you revise a die, that you end up with a better component, but better doesn't always mean form fit function.
Yeah.
There are sort of idiosyncrasies in original components applications that might mean that an enhanced product doesn't actually work in their system.
Hmm.
So it's one of these things that you can only verify through test documentation, providing the customer with data logs, and ensuring that correct engineering samples are done and put into the customer so they can run their internal verification before proceeding with any kind of production lots.
Yeah, I think, like you say, better doesn't always mean that it will work for the customer just because you say, oh, but this is the better version, it's a more modern version, so, okay, well, doesn't work with my system. So, um, another question I have, is it possible to validate form fit function compliance without original manufacturer documentation?
It's a really complicated field, this one, and part of the reason why you're sitting in front of a metric ton of data books, because customers don't always have the full documentation,
Yeah.
nor do OEMs, 15, 20, 30 years ago. Ha- Perhaps they didn't document fully all of the characteristics of that product. Um, it's a very difficult world to get into. So everything starts with the original part number, and then we look to trace back to the exact components that the customer was using on their board, even down to sort of batches and date codes. And in a perfect world, we would get samples of the original component, so we can run verification testing to ensure that our components are going to be as like for like as humanly possible. Um, but it's a very tough part of what we do. Um, and a lot of times, if you don't have that correct level of documentation, you have to take best engineering assessments and review with the customer, sometimes over months, to ensure that what you're offering is going to work for them. Um, but really, there is no substitute for application level testing and characterizing the product to ensure that the data sets that you have are gonna work for them.
Yeah. Yeah, I think that's something that was a reason why we always kind of stress the point of sampling something out, especially when you don't have a lot of that original data. Our engineering team, that you can be pretty confident, but sampling it out, that in application verification, using known good units, things like that will always give confidence to the solution, and collaborating with the customer to say, this is the information we have. This is our line of thinking. What's going to work for you? Give us good feedback on the samples, and just working with them to understand the best approach, because at the end of the day, it's they're the ones using it.
Yeah, it's very much a collaborative approach, and it often is defined by how good the customer's engineering department is, and yeah, just simply how much documentation they have on that. And then as you say, there is no better way than sampling the product in and having them run in system application testing.
It's something we've spoken about in previous podcasts, and it certainly comes up a lot in the kind of sales engineering meetings. But a lot of the engineering and even the procurement teams that we're talking to, they don't know, or it's not necessarily documented their end, why something was tested to a certain specification, or why certain engineering decisions were made, because they were made so long ago.
Hmm.
That is kind of finding a happy medium with all that information or lack of information sometimes, to say, yeah, this is probably a good solution for you. Okay, so the last one is, how would we, as in Force Technologies, ensure a replacement is form, fit, function?
So that's just a multi-step engineering process. Um, the first thing you would do is look to collect all of the documentation of the original part. So that comes
Hmm.
from the part number, and then you look back and see what documentation is available for that product, and look at has the die changed over the years. Obviously, it's very dependent on the solution that we're offering the customer as well.
Hmm.
So once you sort of have got to, for example, let's say we're doing a build, and we've identified a source of a die, or we've got it in our wafer bank that we can build from. Um, then the first thing to do is then look at the package. That's the external housing of the component that people see from the outside world, um, and do a proper comparative analysis about redesigning that package, and ensuring that it's dimensionally accurate, and then passing that information to the customer, saying, "Look, here's how this part will look from the outside world." And then you do internal verification checks to ensure that the die can be bonded out correctly. Um, and then you review the characteristics of the die and do various electrical qualification testing to ensure that the part is performing exactly to the original datasheet specification. Um, and then you're really looking at the environmental testing, and that might not be something where the environmental testing that the original component had was well documented on the original OEM data sheets. It's certainly the case, sort of 30 years ago, that was not the most clear world. And that's where it comes down to what you were saying earlier, that the customer then has, when they are replacing these legacy components, they generally write a more up-to-date specification on, well, what can we accept when we're replacing these components, what levels of concessions, if any, might be applicable, and then ensuring that what we're offering is going to meet their requirements so they can sign off on it.
Yeah, the environmental testing is certainly one that comes up a lot more than the kind of assembly, the die, the package. That's tends to be more straightforward, but
Mm.
actually the level of testing that a customer needs is always one that comes up in conversation. Um, so I think I'm gonna put Ben out of his misery there and let him get back to work. But I hope we've shed some more light on what form fit function means. And of course, any other queries relating to it, just drop us a message or an email or a call. So thank you very much for tuning in.